This is the general structure of carbonyl compound, which central carbon or middle carbon will be having sp2 hybridization. sp2 hybridized 3 orbitals will form 3 covalent bonds. These 3 bonds are sigma bonds. One side oxygen, one side maybe this alkyl group methyl, and this side also methyl. So now there will be one more orbital, vacant p orbital. In that case, what we are taking those orbitals. Let us see that the carbon is having one orbital here and oxygen is having an orbital. So now what will happen? Electrons will be delocalizing from one orbital to another orbital. This is what happens. Yes. So now what is this? This is a 5 bond. C double bond O. This is what the reason why we are writing C double bond O. Okay. This is the 5 bond and this is the sigma bond, sigma bond, sigma bond. 3 sigma bonds, sp2 hybridization of the carbon and oxygen will have one vacant orbital, and these orbitals, in between these orbitals, electrons will be forming 5 bond. This is the general structure of this. The first one, this is the 5 bond. Okay. And this is sigma bond. These remaining all 3 are sigma bonds. And sp2 hybridized carbon will have a planar structure, triangular planar structure. Always let us consider this carbonyl compound, whether here whatever the substituents at the left and right, this carbon and this and this and these 3 bonds will be on the same plane. That you keep in mind. sp2 hybridized will be having triangular planar, and the bond angle between these 2 things will be 120 degrees. This is what the general structure of carbonyl compound. And one more advantage of this carbonyl compound is generally they will form hydrogen bond. That is what the advantage. Even carboxylic acids and other things, they could able to form hydrogen bond. So how this hydrogen bond will be formed in this? Just let us see. This is a formaldehyde molecule. Okay. So now what will happen? This formaldehyde and one more formaldehyde molecule, if you are keeping like this, and if you are rotating this molecule that side, and finally what will happen, there will be so we will delete this and Control Z. Always there will be, what will be the thing? See that now there is a chance for hydrogen bonding. No, this carbon will have a positive charge and oxygen will have a negative charge. This carbon will have affinity towards this oxygen. The reason is this is electrophilic in nature, and that is nucleophilic in nature. That's what the reason. There is a chance for attraction between these two, and there is a chance for attraction between these two. These are the things which will, yes, this is the special nature of carbonyl compound, and always this is an electrophilic carbon. And one more thing, any carbonyl compound which is having alpha hydrogen, those alpha hydrogens are acidic in nature. That you keep in mind. These alpha hydrogens are acidic in nature. So what will happen now? If you are sending a nucleophile to this powerful nucleophile, it will attack on electrophilic carbon. Or suppose if you are adding any base, the base nature will be abstracting the proton. That is hydrogen from this methyl group. That is what alpha hydrogen. Base will abstract proton and it will form CH2 minus, plus and minus. That is very stable. That's what it will happen. These are the structural aspects of carbonyl compounds. And so now we will go for the preparation methods. What are the preparation methods for carbonyl compounds? First, we'll see the headings. What are the preparation methods? The first one is from acid chlorides. From acid chlorides, we can get carbonyl compounds. Second one, acid chlorides and even nitriles also you can add in this itself, because same reaction. Acid chlorides and nitriles. And second one, under these acid chlorides we are having some reactions, and from dithianes, 1,3-dithianes. This is like a special reagent. From 1,3-dithianes we can make carbonyl compounds. This is the advantage of this reagent. 1,3-dithiane is an reagent. Aldehydes or ketones, both the things can be prepared by these acid chlorides and nitriles, and 1,3-dithianes and carboxylic acids. From carboxylic acids, as a fourth, if you want to make alkyl and aldehydes and aryl aldehydes. For aryl aldehydes, the oxidation of phenol, that is even oxidation reactions can make aldehydes, and any primary alcohol will give us the aldehyde. Any secondary alcohol will give us the ketone. And Friedal acylation also will come under this category, because we have already discussed this Friedal acylation and alkylation method. For acetones, for carbonyl compounds, Friedal acylation, because acyl CH3CO plus will be generating there, the benzene ring will be reacting with that acyl acylinium fragment, that is the intermediate. There our benzene electrons will be attacking, and due to hyperconjugation we are getting the compound. These are the 5 important reactions which we are going to discuss, preparation methods for carbonyl compounds. So any acid chloride or any nitrile compounds, they are the derivatives of carboxylic acids. How we can prepare carboxylic aldehydes from this? Just let us take directly the reaction or COCl COCl, that is acid chlorides. If they are reacting with lithium reagents, we will get aldehydes. That is what the we will see the now acid chlorides to aldehydes, how it will form, what is the reagent we have to use. For this reaction, we are using lithium reagent, lithium alkoxyaluminate. That is what the thing we are using here. Lithium aluminium hydride is a reducing agent, but in order to reduce the reactivity of lithium aluminium hydride, what we do, just we will keep aluminium reagent small l and capital H, O tertiary butoxy. This is what thrice, and the temperature of the reaction is minus 78 degrees centigrade. This is what the reaction temperature. You see that this is very critical. Low temperature reaction, and ether is the medium. This is what the conditions for preparation of carbonyl compounds. You see that we are getting aldehydes. We are getting aldehydes from acid halides, acid chlorides. The reagent is this trialkoxy lithium aluminium hydride. That is what the reagent. If you at minus 78 degrees, what will happen? This will form directly aldehyde. This is forming directly aldehyde. And one more reaction we see. What is that? Normally these reagents, special reagents will be there selectively. If you use those reagents, directly will get the carbonyl compound. And what is the source for this acid halides first? For acid halides, the source is, for acid halides, source is RCOOH. RCOOH will give us RCOCl. This is what that means from carboxylic acid only we are getting the acid chlorides. These are the derivatives of carboxylic acid. What are these? These are the derivatives of carboxylic acid. So now what is the reagent for this? If you want to get this acid chlorides, because why we are discussing this thing is, anyway carboxylic acids are the selective for us. Anyway we have to discuss, because it is a carbonyl compound once. SOCl2, that is thionyl chloride. Thionyl chloride, if you are using, what will happen? Directly we will get the RCOCl. For any acids, if we are treating it with thionyl chloride, you will get the, and So for any carboxylic acid, if you are reacting it with ammonia, what happens? If you react with carboxylic acid with ammonia, you get carbamate. Those carbamate, if you are reacting with P2O5, what is the carbamate? COONH4. COONH4. That is what carbamate will be. This carbamate, if you are heating in presence of P2O5, you get RCN or CN, that is alkyl nitrate. So now this is what the reaction. So now what is the reagent for the first one? Ammonia. Carboxylic acid, if you are treating it with ammonia, you get carbamate. This carbamate on reaction with P2O5 and will give us alkyl nitride. So what we should do, we should wait for this thing just. This is the reaction. In presence of ammonia, carboxylic acid will form carbamates. On carbamates, again on heating it with P2O5, they will be generating alkyl nitrides. That is what the reaction. How will you get acid halides? Alkyl nitrides. This is the reaction. P2O5 and heating will give us the alkyl nitride. Now these alkyl nitrides, if you are treating it with an special reagents, directly we will get aldehydes. That is what the advantage of alkyl halides. You keep in mind all these are the getting aldehydes or carbonyl compounds from these acid halides and alkyl nitrates is a single reaction, but anyway just how we are getting acid halides and alkyl nitrates, that is also one of the important thing. If you are using any lithium aluminum hydride reaction or reagent here, what will happen? Directly it will form, that is what DBAH, diisobutyl aluminum hydride, DBAH. You keep in what is DBAH, diisobutyl aluminum hydride. This is how the structure will be. The structure of that reagent will be aluminum. We need an aluminum to draw that. And 3 bonds will be there for aluminum. Just we are writing first all. Okay, all are. Let us assume one is hydrogen and another 2 are isopropyl groups. This is what isopropyl. You can remove this maybe even if you want, this is what DBAH. This DBAH, this alkyl nitrides and DBAH, if you are, what will happens? The name of this reagent is DBAH. DBAH. You can write it in capitals. Alkyl nitriles, that is RCN. If you are treating it with DBAH or CN plus DBAH will gives us the RCHO. That is what the reaction, and this is the reagent. You keep in mind DBAH. Selectively, if you want to get aldehydes from this compound, what we are using? DBAH. This DBAH is a reagent. It is a selective reagent which is converting alkyl nitriles to aldehydes. You keep in mind DBAH is diisobutyl aluminum hydride. And previous one, even this LBAH, you can write this is LBAH. It's what is the thing? LBAH and DBAH difference is, here aluminum will be having 4 bonds. One more alkoxy thing will be tertiary butyl alkoxy, that is this. Let us delete this and iso tertiary butoxy, that means tertiary butoxy group should be there. This is the structure of LBAH. You see that the name of the things, and these are somewhat LBAH. What is LBAH? Lithium tritertiary butoxy. Even we can write. These are the reagents. Directly we are getting carbonyl compounds from that. Lithium you lithium tri-tertiary butoxy aluminum hydride, that is LBAH. This is the reagent for acid halides, that is RCOL to RCHO conversion. Even we should explain the structure of this LBAH and DBAH. That is what very important. And you write DBAH abbreviation also. That is also important. Reason is simply if you are writing DBH, nobody knows what it is. Diisobutyl aluminum hydride. This is what the DBAH structure, okay. And now this is one of the preparation method. That is the first one. What we have discussed is first one only, acid chlorides and acid this alkyl nitriles. If you are treating this, how you are getting acid chloride and nitrile? This is the method. And even sometimes there is a chance to ask mechanism. That is also one possibility. And normally what will happen, or COCl case, the Cl will leave because of RCOCl. I will show the structure for that. RCOCl. Let us take, this is the RCOCl. Okay. So now in this RCOCl, what, instead of Cl we are keeping OH, but anyway we will keep this. This oxygen is having electron pair. What this electron pair will do, this electron pair will be shifting to this, and this C, and sorry, this pi bond will shift first. We will see, we will write it in reverse way. What happens? CO minus will form, and O minus again, if it is coming in reverse manner, that is, let us assume this is already, O minus will come. Again O minus, if it is forming double bond, means this Cl will leave. That's what from acid halides, how the reaction is happening. Normally this reagent, what it will make, this is what happens. This arrow will not be there now. What happens? This O will get negative charge. This oxygen will get negative charge because now this will, that is what polarization we are talking. Electromeric effects. Electromeric effects, what will happen? In presence of LBAH, what will happen in presence of LBAH? This is what happens. Again, if suppose hydride ion transfer will happen, so hydride ion transfer will happen to where? This carbon, this LBAH will transfer the H minus, that is hydride ion transfer. This hydride ion transfer is, so very, very important step here. Next step, the mechanism of formation of aldehydes from acid halides. Here you write hydride ion transfer, H minus instead of that, hydride ion transfer. Okay. If hydride ion transfer is there, what will happen? This carbon is having negative charge and one hydrogen also is coming as an extra. So now what will happen? Already hydrogen is there. Now this O minus will shift here and we can use the same arrow. So now in reverse manner, what will happen? And now this will be reversed. Yes. That means depolarization will be happening once again. Electron, that minus charge will form double bond at this point and Cl will leave. That is what the mechanism of this reaction. This is the mechanism of this reaction. Okay, keep in mind. So now finally what will happen? It will form aldehyde. This is the mechanism for this acid halides to aldehydes. What happened at the end? We got this is the mechanism of DBAH, how it is working in 3 steps it is. And similarly, you can practice it for acetic acid to acetaldehyde preparation. This is acetic acid only. Let us acetyl chloride, how will you get? If you react acetic acid with how will you get acetic acid chloride? Now acid chloride, if you want to get, we are treating it with SOCl. We know the reaction already. We no need to worry. Directly, if you get what you see, instead of OH, you will get Cl. This acetyl chloride, you are treating it with our reagent that is called LBAH, and you will get finally that's the same reaction will be continued and you will get finally acetaldehyde. Acetic acid to acetaldehyde conversion. You see this is very, for looking it is simple, but you should understand well. Otherwise, while writing mechanism, it will be. It is the next reaction, Rosenmund reaction. First reaction, acid halides, and this thing is over. Next reaction, name is Rosenmund reaction. This is one of the important reaction for aldehydes preparation. Rosenmund reaction, what it tells us? Acid chlorides in presence of HCl, H2PD. Acid chlorides in presence of, we will copy this reaction same as it is. Only the difference is reagent. We won't use this reagent, but the reagent is now different. That is called H2PD, that is hydrogen, palladium, bor, palladium reagent, and BaSO4. Barium sulfate will be there. This is called even Lindlar's reagent. Sometimes I will tell you. This is Rosenmund reduction. Keep in mind. H2PD, BaSO4. What happens? Acid halides are becoming aldehydes and acid halides are becoming aldehydes. This is the Rosenmund's reaction. Okay. Even benzoyl chloride, same reagent if you are using. Instead of R, you can write CH3, or instead of R, you can write AR also. That is what? One more method. And from Grignard reagent, whether ketones can be made. That is what we are going to see next reaction from Grignard reagent. Grignard's reagent, anyway, We have not seen much about Grignard reagent reactions in the alkyl halides. Here we should RCOCl, if you are treating it with Grignard reagent, what happens? Grignard reagent, we know the structure of Grignard reagent, simply RMGX. What happens if you or MGX? Now R is having negative charge. This R is having negative charge, Mg is having positive charge. Now what will happen? This R minus R will be having negative charge. Now what will happen? R will attack on carbonyl carbon. That is what happens. Yes. So now what will happen? Cl will leave. That's it. You will be getting finally ketone. R is having negative charge, and now what happens? The Cl will leave. Because carbon valency is 4, not 5. That means it cannot form more than that bonds. It should leave. And one more thing, it is having best affinity to leave. That's what it will leave. Now finally what happens? We will get RCOR. Finally we are getting just instead of Cl, we are getting R. That's it. We are from Grignard reagent, we are getting ketone. Acid halides, if you react with Grignard reagent, what happens? R minus will attack on this thing, and finally you will get MgXOH. Is an MgX2, because you can write directly here Br or Cl instead of X. You can write MgXCl. This is from Grignard reagent. If suppose any other organometallic reagents which is giving the same reaction, not only Grignard reagent and even alkyl cadmium or alkyl copper. Alkyl cadmium reagents or alkyl copper. Dialkyl cadmium or dialkyl copper. You keep in mind what is that? Dialkyl, you can write directly, or 2. And this 2 should be not in superscript, it should be an right, or 2, yes, over. Next, CD, cadmium reagent, or same R2Cu. That is what they, dialkyl copper or dialkyl cadmium instead of Du. That is the reagent which we can use to convert acid halide to, see these are the all preparation methods for carbonyl compounds. You keep in mind, very important for organic chemist. Finally, you will be preparing, yes, this is what the ketone what you are getting from organometallic reagents. Okay, next, up to now only one method we have seen. What is that? Acid chloride to aldehydes, acid chloride to ketones by using LBAH, DBAH and Grignard reagent. See that three examples, important examples we have seen.